guys. Okay, we're on the second stage of the CNC build. This is going to be, we've got up here this is the Z, the Z. It's going to be the vertical, so this will ride up and down on, when this turns, this guy will go up and down, and that'll be attached to the gantry, which will be this bit, so kind of like that, and well, like that, with the motor on the top, fixed to the virtual gantry, and then somehow the router will be attached to this guy, and then that will go across, and there'll be some vertical supports down to the main base. We got the end plates here on the plate. The plate's a lot bigger because rather than it being inside a seat profile, now we're going to have the wheels on the outside. So anyway, we'll start putting the wheels on. Okay, so these holes are not pre-tapped, so we have to do that. They actually did tap quite a lot of the holes, which was, I didn't expect. Behold, the amazing cheap and nasty tapping kit. La la! So we've got the side plates on now. I moved the gantry to the end so it helped calibrate how high that lead needs to be. So you're pretty much using the thing, what it's going to be running on. So you're not getting any binding when it's normally used, because it might bow over if this was lower. And so I brought that to that end and took it to that end and adjusted these. I loosened them, let it align it itself, put the bearing in and let it tighten it up again. And that seems a lot better. I mean, it's really nice. See that rolls. Yeah, I was just playing with this assembly, and the actual bearings, they've got like 1,000, well even more than that, they've got like, you can see that. It's quite a lot of play. It doesn't look a lot when you wiggle it around in there. I would say it's about a foul or less, but you can see there. Quite a lot of play. The thing is with bearings, normally they're an interference fit, so that means the bearing is slightly bigger. I mean, we're talking like 10 thousandths, so it might be 5-10 thousandths, slightly bigger than the hole they're going to go in. And there's different methods of installation. So you have, I think swaging is where they have a special bit of equipment, and it's like a roller, and it'll roll around and push the bearing in there, and you have little chamfers on the bearings that help with that installation. You have heat treatment, so you can heat the part up. So this actual housing you could put in the oven, it'd expand just enough. I mean, just those tens of thousands is enough. Then you slip the bearing in and let it cool down slowly. then it will make a snug fit also. And then there's press fit, so you could just basically a vise with the correct spacers, so it mounts on the racer and on the middle properly and keeps it all concentric. Then you can press fit in there, so that's like just a conflict clash, if you will. Now with this, I've done before for test equipment, I've done just using thread lock, and if it's just something like this, I think thread lock's fine. So I'm going to put some thread lock around here, and that should fill the gap in, and it should lock the outer race with the mount, which is what you want really, and then the bearings inside are doing their work, because at the moment I think the whole thing's trying to turn almost.